All right, what's up, people? We're back at it. Uh, basically 5 o'clock almost. Went to the gym and I went to Mickey D's to get the free fry Friday. Spent $2 on a coffee. I ran a mile in 6 minutes and 57 seconds. My calves were like a little bit sore. I don't really know why. Like I've been on leave at all. My calves were like sore, but I was like, I didn't think nothing of it. Ran my little mile, smashed it, almost died in the process. But then, dude, I was done with that mile. I couldn't even walk away from the treadmill. I had to go sit down right next to the treadmill on the little rowing machine or whatever. I had to sit. My my calves were just like literally. I don't know if my I don't know if my calves have ever been this sore. Yeah. It might be because I've been out of work for a while and my muscles are like it's degenerating. I don't know. Oh, we had finished ensuring places in setters and getters that utilize a lock have acquired at the correct location. Cool. Now that took a really long time, much longer than I wanted it to take. Now we are going to verify that internal use adders are locked outside of setters and getters. So this should be easy. File. So, and we're going to find, we can just go up here to Alright, so we're going to open them one by one. And we're looking for internal use adders, right? And these are always associated with setters, calculated properties, that is. So that one doesn't have attributes because doesn't have a class in it. Doesn't have any transferred attributes. This one doesn't either. This one, it doesn't have it does have a class, I'm tripping, but it doesn't have any transferred adders, so we don't have to worry about that. And same for custom time list. Right, deck has these three, but they are not race condition prone. Okay. This game is definitely gonna have some. Alright, here we go. So here's what we're gonna do. We're gonna choose multiple cards. Okay. And we're going to look for the internal form of that. So we're going to do underscore choose multiple cards. We're just going to see everywhere that is modified. So that one's safe. Next one is going to be click card active. Alright, done. Enter continue text active. Done. Game state. Alright. Done. Input text final. Alright, that was easy. Done. Okay, so our next issue would be lock, acquire, release logic. Triple check these locations wherein we are manually not using with acquiring and releasing lock to ensure logical security. I that the release would always be connected to proper acquire, that the acquire would always be executed prior to a subsequent release. Alright, I had that backwards. Anyway, all we have to do is look for acquire, and let's see what we got going on here. Okay, so we acquire here, and then we check to see if that lock is acquired. If it is, we release it, so that's good. Same thing with selected choice lock, we acquire it. If it's acquired, we release it. Same thing with click card active lock, we acquire it. We check to see if it's acquired, and we release it. Clicked card lock, we acquire it. Then we check to see if it's acquired, we release it. Progression text lock, we acquire it. Then we hold up. Oh yeah, that's right. Yep, then we check to see if it's acquired, and then we release it. We acquire the enter continue text active lock. We check to see if it's acquired, and we release it. Multiple choice active lock, and we acquire it. Then we check to see if it's acquired, and we release it. Enter continue text active lock. We acquire it. We check to see if it's acquired. Then we release it. Multiple choice active lock. Acquired. Checked. Released. Multiple choice text 1 lock. Checked. Released. Multiple choice 2 lock. Checked. And released. Choose multiple cards reentrant lock. Checked. And released. Wait, what? Okay. Gotcha. Okay, acquires text input active lock. Acquires input text final lock. And then the release for it if it enters into this, and then else it will release it. So either way it gets released. And then we have the input text final lock, which gets released if and also else. Same scenario, I think. If it's released, else it's released. If release, else release. And again, or wait, is this the same code? Yeah. Alright. I'm done. Transfer lock acquire. Let's make sure we release it. So we release it if, and transfer lock. So this is going to be, so that means transfer lock is a reentrant lock, right? Oh no, it acquires it, then releases it, and then it acquires it again. I'm tripping. And then else it releases it. Alright. C1cal reentrant lock gets acquired. Then we release it if else we would release it. Then we have the same thing but with C2 cal reentrant lock. We acquire it if we release it, else we release it. There we go. That's done. Alright, next thing is going to be check for shared object among non-adders. So I realized that we actually need to check for shared objects among non-attributes since we already checked all adders. Okay. They're just prone to risk conditions and need to be checked. Don't forget class instance objects such as P1 game. So we'll start at the top. Just work our way down. Okay, so face down image file, that never changes, so that's going to be fine. The face down image, that's going to be fine as well. Data transfer, it's not transferred, so we don't have to worry about any of that. I'm trying to think what would qualify. Like, I don't want to think too hard about it. We'll just go through, and I think it would just be faster to just go through. Alright, so we have SS or CS being equal to none. You know, this, well, no, we only set that once. We set it once, We yeah, we set it at the very beginning of the game, so I don't think we would need a lock. We check it a lot after, but we don't modify it. Okay. Now what about change attribute list pi client ID? Well, that gets set at the very beginning of the game. That's it. So we don't have to worry about that. Cameras used to be C1, C2 to avoid using locks. Can't we change this to be C1, C2 to C1, C2 to avoid using locks? We could use this change in tandem with 2x connection sockets per client to avoid using locks at all. Think about that another time. Alright, so C1 change attribute list currently does have locks. We have locks associated with them. I think because yeah, they are the original objects which are handled, and that's what these reentrant locks are. Okay. We have the apply counter. Does the apply counter need a lock? Let's think about this for a second. So the apply counter is used I don't think it needs a lock. So we globally access it through data transfer function, which this is going to happen client side and server side. It gets incremented here in data transfer function, and then same place, different part of the function. Then it gets included in the cal tube. But it just gets added to the cal tube, and then the cal tube gets added to the change attribute list. So like, and at that point it's just an integer that's been appended to this tuple. It has no bearing because it's an immutable type object. So Yeah, we're good. All right. See when apply counter is not, doesn't need a lock. Okay, so which file was that? Was change attribute list, so we can go to client. Transferred adders, non-transferred adders. We have change attribute list and ID, but this is a different change attribute list. We already locked that, and the ID doesn't need a lock. But let's just see. There might be other things. The time tube, no. Well, this is client side, so we're not going to need a lock there, so we can move on. Custom append list. Yeah, these are just methods, it's not going to need anything. Custom logger. So, what about the card objects? I forgot about that. Yeah, the card, the client objects. Let me add these. Let's see. So move this up here. All right. List of objects, and then we have card instances. Client, I would say client 1, client 2, and then the custom append list instances. The custom logger instance. Never really thought about that, but this is something I do need to think about. I'm glad I some timeless instances. Deck instance. Game instances. Locations instance. Network instance. Yeah, like the connections. What about cons? Already locked? I think the cons might already be locked. Player instances. Server instance. I don't know, man. It depends. Okay, so this is stuff that it's gonna require some thought. I'm not just gonna be able to figure this out like in a couple seconds, unfortunately. And then we still have to check, also check inside of each file for other non-instance objects, non-class instance objects. And we did that with card is done. And the next one we did was changed attribute list. Next one we did client, and the next one is we did custom append list. Next one was custom logger. Next one is custom time list. And what's next? Deck. I don't know if we checked the deck. Did we do deck? Okay, yeah, we actually didn't finish custom logger, so we're on custom logger. I got a little bit ahead of myself there. Let's see, custom logger is current, and then this is dot 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 dot. Why is car? Oh, because I deck. Next one, DTM set. We don't need. Doesn't change. Next one, locations. Next one is network. Next one, player. Progression. And server. And then setup. Okay, I gotta use the bathroom. I'll be back. Alright, so let's keep doing going through custom logger. So the actual custom logger instance, well, we'll handle that after because we're going through the miscellaneous objects first. So the on-off switch, it is set to true to print logs at the end. Set to false to not print logs. Okay. Yeah, we don't have to worry about that. Print log switch. Yeah, we don't have to worry about that either. Okay. Custom logger is done. Alright, custom time list. Current. Let's open it up, see what we got. Okay, so those are all methods, we don't have to worry about that. Deck. Let's see what we got here. Okay, so the only thing is the actual deck object, because we already reviewed adders, remember? We have DTM set. Yeah, DTM set's just irrelevant. Okay, game is the big one, huh? Game is huge. Shit. But we want to get out of the attributes, like, so let's just go all the way down, and yeah, so everything is an attribute, so that one's actually really easy, which is cool. Alright, locations, next one. Did adders, which there aren't any locations, so these are all methods and stuff. None of this stuff is transferred, so we don't have to. Well, okay, hold up. Well, just because it's not transferred. Well, actually, hold on. Let me think about this. Yeah, if it's not transferred. Yeah, if it's not transferred, that means the client threads aren't going to touch it. So only the main thread's going to handle it, so it's safe. Yeah. So all this should be safe, and then we have the func dictionary, which doesn't change. Yeah, so we should be good here. Oh shit, I forgot to put done right here. Deck, we did deck. We did game. We just did locations, right? Yeah. And then network. So that one up. So yeah, basically if it's not transferred, then we're safe, right? Okay, well, to be more specific, if it's not handled by the client threads, we don't have to worry about it. Now, the network object itself, well, that might only be used by the client threads, and it wouldn't be used by the main thread. I don't know if that's true. I have to look that up, but that's we're working in miscellaneous stuff right now, so that is done. Now player. progression. Progression is only main thread. I don't think we need this logger anymore. This is like old. Okay, yeah, so this is all main thread, like, yeah, we're safe on progression. Alright, server. So we don't have to worry about attributes. Okay, so I need to review server more because server actually, we were going off of the idea that it didn't have transferred adders, but I just realized that it doesn't matter if they're transferred, because the server like objects, these attributes are shared between the client threads. So the client threads are on the server side. Obviously, we have the main thread, the two client threads. So if we have con1 being used by thread 1 and con1 being used by client thread 2, which we do, and I'm quite certain we do, and we have locks in place for that, which, yeah, there it is, con1 lock and con2 lock. That means that there's other attributes that are shared. They're competed for, not between the main thread and the two client threads, but just among between the two client threads alone. They're competed for. So I think, yeah, we definitely need to review it a little further. Check non-transferred adders because they are still shared between client threads, such as con1 and 2. So we'll come back to server. We can knock out those last one real quick, which is going to be easy. It's going to be set up. Well, maybe it's not. Card ID. For each card's ID, this number they go to +1 every time a card is created. Okay, then we have the function. And this is executed only once on each endpoint, so this should be good. So yeah, so like they don't have to be transferred for them to actually be shared. And this is just like, damn, I didn't realize that before, because I was just assuming, I was so stuck on the whole main thread competing with the client threads, I was forgetting that just the client threads can compete with each other. So like, yeah, this means we actually would have to review all non-transferred attributes that are handled by the client threads. But I'm thinking, oh man, that's a lot to check, because all those non-transferred attributes, there's so many of them. But I know that's not true. Like, I know we don't have to check all of them. I know I can create a subset of parameters that would narrow that list down tremendously. Because like, obviously it's only if both threads compete for them. What is this? Okay, alright, so yeah, we have non-transferred attributes, but like, for instance, like connection 1 and connection 2, those are not transferred, but they are shared, because each client thread has to transfer data to each associated client, to both of them. That's just the way that we have it structured. So I'm trying to narrow down the list. Like, let me... Okay, so setup should be good. I see this, locate, resituate cards, no sound, but like this is inside of the setup function. This only gets run once per endpoint, so I'm 99% sure that should be safe. So now we have to add a new thing to do. Check for shared objects among non-transferred adders. Damn it, I realized that transferred adders have to be checked for thread contention between C1 thread and C2 thread. They are still shared between client threads. And we can copy this. We forgot to change this one to done. Shit, man. Alright, that sucks, man. That really sucks. Well, I mean, it doesn't suck that I realized something that I needed to realize, but it sucks that I realized I have more work, and that just always ends up happening, doesn't it? Damn. Oh well. It is what it is. No point crying over what's done. So we need to check all these. Card instances. Alright, so do one thing at a time, and this one is gonna happen after we do this. It's not gonna take that long, bro. It's just another thing you gotta do. Don't stress about it. Okay, check for shared objects among non-adders. So now we have to check. Okay, so let's look at the card instances. And I'm probably just gonna go this 25 last minute, 25 more minutes here, and go ahead and call it quits for today. Feeling a little worn out here. Oh, you know what? Before I do anything else, test before changing anything else. And you know what? I'm gonna just leave this here. This needs to stay here because this is one of the most, like, this is the most important thing. Testing before, after my changes, and I have gotten really bad about not doing that. And that is like not good. That is not a good practice. That is one of the, like, that is probably the worst practice you can have in programming, is not testing after like almost every little change that you make. So we're gonna go ahead and do a little game testing. Maybe it'll give me a little dopamine spike here because I'm feeling pretty bored with this right now. Burnout on the project overall, and look at this shit, we're not even getting any output. So okay, here we go. Thread lock has no attribute acquired. Thread lock acquired. Let's go. What line is this? 534. So let's go to game and 534. What we got here? If self game state lock acquired is equal to true, so game state self dot game state lock acquired thread lock object has no attribute acquired. Is it not a method? That's not how you call it? Is that not how you call it? Let's see. Python lock acquired lock dot acquired if lock dot acquired. Oh, you don't have to. Oh, I see. Okay, so you just run this is a method, and it returns true or false. Did I spell it wrong? Acquired. Acquired. No, I didn't spell it wrong, did I? A-C-Q-U-I-R-E-D. A-C-Q. Yeah, I didn't spell it wrong. I guess what you don't check if it's equal to true. It would be like saying if true is equal to true, but that shouldn't be invalid. Thread lock object has no attribute. Acquire. Has no attribute acquired. Did you mean acquire? Okay. So let's just try it by removing the okay, so now we're just waiting other player. Alright, so I know what I gotta do. Let's look for all instances of acquired. Am I? It's just AQ, bro. I'm fucking dumb. Or is it? Is that what it is? No, man. It's acquire, right? Because when you AC, why does the word look so weird now? It's like Dumb and Dumber. When you look at the word road, it looks weird. Roads. Acquire is turning into acquire. What the fuck is this? But what's the problem? If it's acquired, that's... What is this? Hold up, bro. Why is this not working? Okay, kill the terminal. I don't know what was going on with that, but let's see how dumb I am. Not really feeling very sharp right now, so thread lock object has line 534. Game state lock acquired. Thread lock has no attribute acquired. So is this like what? Python lock dot acquired? If Python lock, oh, is it just an attribute? Is that why it's just supposed to be an attribute? Bro, why does that word look so... Am I tripping, dude? And it's not letting me kill the script. Why? Why is this? Just gotta push through it. Push through it. Push through the shit. Canasta main, Pi client. Thread lock attribute object has no attribute acquired. Same thing. locked. Locked. The locked is an inbuilt method of the lock class of the threading module. It returns true if the lock is acquired. It's not acquired, it's locked. Dumbass. Dummy. Isn't it actually got locked? You're absolutely right. The correct method to check is locked. Asshole, come on, Gemini. You had me thinking I was right all this time. So all this, yeah, I was supposed to put locked. Dumbass. You still can say like locked. So I can just. So they're all in this file. So we'll just do acquired and we'll change it to locked. Acquired, locked. Alright, let's see if that fixed it. I'm dumb. That was a simple mistake. Silly goose. Alright, there we go. I think we're okay, we're cooking now. We're cooking now, boys. Damn, bro, I forgot to take the chicken breast out of the fridge. Shit! Shit! Oh well. Damn. Yeah, I get caught up coding and I'm just like... Forgot. Whoop, whoop. Thread rlock has no attribute locked. Okay, so we have choose multiple cards, re-entrant lock. So this is line 971. Right here in front of me. Isn't that funny? Whoopsie. Control Shift F, Control F. I don't like all that stuff being there. See what's locked. So re-entrant locks don't have the locked method. So all this like if we do if false, I mean this is the most basic, like just dumb question, but I just forgot. I just forgot. Like I'm 99.9% sure about this. I just need to be 100% sure. If false, print true. So like it wouldn't print true, right? Right. Okay. Yeah. Not gonna print true. Let's run it again just to yeah. If false does not print true. No, you think this had to be certain. So, but if true, obviously is gonna work. So if we were to just put if true, print true, and then run that, we get true printed out. Which means we don't have to, like, there's lots of places where I do equal to true, which is fine. Like, it's no big deal, but I could just do if true. Like, I could just do say if choose multiple cards or enter that locked. But it's probably like 1 microsecond, nanosecond difference. So I'm not going to change that code. As a matter of fact, the one that I did change, I actually want to change it back. So game state locked is equal to true. I actually like it to be written out that way, even though it's technically non-optimized. It's more better in my opinion. Okay, so where are we at here? Let's get rid of this debugger. Okay, so that's right. The rlock doesn't use the locked method. That is actually news to me. I did not know that. Now I do, and now I'm a little smarter than I was. So, how do we... So I need to figure out what are... I know what I could do. A real easy thing. I can just check if change attribute list is equal to SS at the end. Bam. Because if it is SS, that means we did acquire it, and that means we need to release it, duh. But just because I like to know everything about everything, I want to go ahead and first take a whiz, because I gotta use the restroom. I'll be back. Okie dokie, Smokey. Where we at? Change it to be this. Blah, blah, blah. Yeah, so we want to see what are the R locks, and man, I don't even use Google anymore. Like, you know, that's like Googling stuff versus using Chibbity Jibbity, and Gemini is like using MSN search. You know what I'm saying? When and how to use Python's R lock. You know, they always say read the docs, but why is it always so hard to get Google search results? Like, wouldn't the Python docs, when you Google Python rlock, wouldn't it show? You know what I'm saying? Well, there it is. I'm an idiot. It did, in fact, show it. Shut up. Shut up. Don't call me out like that, bro. A reentrant lock is a synchronization primitive that may be acquired multiple times by the same thread. Internally, it uses concepts of owning thread and recursion level. Yeah, I like that. That's my word. In addition to the locked, unlocked state used by primitive locks. I don't know what they're called, primitives. What's primitive about them? If in the locked state, some thread owns the lock and unlock. Yeah, duh. Okay. Reentrant locks support the context management protocol, so it's recommended to use with instead of manually calling. Okay, but don't regular locks also support context management? To handle acquiring and releasing lock for block code. Our locks acquire, release, callbacks may be nested, unlike locks, only the final release, the release of the outermost pair. Resets the lock to an unlocked state. Yep, okay. So using pairs. Gotcha. Alright. Class threading rlock. Arrangement lock. Yeah. Is actually a factory function which returns an instance of the most efficient version of the concrete rlock class that is supported by the platform. I don't really know what a factory function is, but I'm guessing it's like a variable function that depends on which platform you're using or something. Anyway, what methods do it have? Because it don't have locked, apparently. Release condition objects. But that's it. There's nothing else. That's all. That's all it has. So there is no locked. Okay. How do you know if an rlock is locked if it doesn't have the dot locked method like regular locks do? How do you know if in lock? No. Let's see. Misser. How do you know if a re-entrant lock? Damn, is my mic that bad? How do you know? How do you know if a re-entrant lock is locked? Locked. My mic must be really going bad. Did I? Well, if it don't, it don't, bro. If it doesn't have it, it doesn't have it. Python rlock locked. Rlock check if locked. You have to use a try except. Why does it not have well, that's weird. That is weird, isn't it? Alright, we're done. Timer's up. We're gonna stop for the day. I'm gonna go fucking play some Overwatch. Take out some chicken, cook some chicken, go play Overwatch, eat some food. Yeah, so we are gonna see. Yeah, we're stopping right here. What exactly? Okay, so we're debugging first. Finish game test debugging. And we'll just copy this right here. There we go. And 6:15. Begin game testing. And we also checked in, well, it's not important. Begin game testing to ensure most recent changes didn't introduce new bugs. And they actually did. Stopped at line number 15 and things to do. So 6:16, 6:18. We're gonna stage and commit our changes. So we went from 4:56 to 6:18. That's an hour and 15 plus 8 minutes, which is an hour and 23 minutes. We'll just say an hour and 15, so we went 3.25 altogether. So now we're gonna cd out to the root project directory. We're gonna do git branch to see if we're on the right branch. We are on the right branch. We're gonna do git add. We're gonna do git commit -m, paste in our dev log. We committed our changes. We have 11 files changed, 145 insertions, 81 deletions. We're going to git push Canasta secondary, so it's the repo then the branch, the repository then the branch. It's successfully pushed, so now we can go to our programming. We're going to go to projects, Canasta. We're going to copy this. We're going to go back out, go to the backup, delete the old one, paste in the new one. We're going to enter into it and make sure that it is indeed correct. So go to the end, 10/18/24. That is the date today. So we can go to the folder for the backup, change this 17 to 18 to reflect today's date. There we go, guys. Alright, I'll see you next time. Have a good one. I'll probably see you Monday because I'm gonna have my kids tomorrow and Saturday and Sunday, pretty much all day. So see you Monday. Have